Our next speaker and the last of this session is Ranjan from Newcastle University. He's going to talk to us about the Edge AI Hub.
I send the slides, yeah. I don't have a laptop.
You can use the chair if you want.
No, I can stand, it's fine. So how do I change the? Okay. Right. Okay. Okay. Good afternoon. Thank you very much for inviting me. So, in this brief talk, I will talk about the UK's National Edge AI Hub. It's one of the hubs funded as part of the AI hubs. I think 1 year ago. It is hosted at Newcastle, but we are a consortium of 12 universities. So today what I will present is, of course, Hub has a broader vision, but how we want to work in federation area, considering the AI layer, AI paradigm, and how the learning paradigm such as federated learning can actually solve the interoperability and cybersecurity problems. I will try to talk from that perspective and then see how our capabilities align with the federation ethos per se, not just edge computing, but traditionally cloud data centers as well. So just to give a brief overview of what our mission is as a hub, our mission is how UK companies can use Edge AI in a safe and secure way. As you can see, all of us work in computing. Edge AI is quite broad, and most of the when we build the AI pipeline is not just edge. The cloud always comes into picture. So, but again, when we are writing proposal, we have to show niche to EPSAS reviewers, so we have to focus. But inherently, I know that any AI pipeline we built will go through edge, IoT, cloud continuum, through all the layers, and then ensuring safety and security is always a challenge. So that makes our vision very broad. But now sticking to the point why Edge AI is important, if you see on the picture on the right-hand side, it's from Gartner. You see the Edge AI sits in the core of the AI revolution. And the main reason for that is Edge AI sits near the data, near the sensors, devices, drones, autonomous cars, which are producing those data. And Edge AI will be responsible for ensuring that that data is reliable, the quality is good, because if the data is tampered with, and if you use that data to train your models in the cloud, your model will not work. That's why getting Edge AI right is very important for other AI paradigms to flourish and work correctly for other disciplines. And on a little bit on the left-hand side, obviously, Edge AI market is booming. A lot of companies want to get Edge AI innovation into their product chain. And we need to, so along with doing fundamental research, helping companies, our other ethos is how do we help train next generation of MSc, PhD students to supply to those companies. So our ethos is quite broad in that perspective. As I can see here, when we wrote the bid, we had 55 companies across different sectors. But one thing I would like to say that given 12 million funding and 5 million going to overhead, we cannot help all the 55 companies. So although all these companies are there, they need help, but we cannot help all of them. We are trying to help at least half a dozen of them with serious investment from the hub and serious investment from the companies. And as far as other companies are concerned, they serve on the industry advisory board. They give us input. We keep informing them how Edge AI innovation is going to help them and perhaps train their people, because we don't have the capacity to create 55 different projects. It's just not feasible. Little bit into detail why Edge AI. Edge AI is a paradigm which is different than cloud AI. And why it is different? Because as I said, it sits near the device. It sits on your autonomous cars. It sits on your drones. It sits on your machine in the smart manufacturing sector. It can sit on your smart grid architecture. And while sitting there, it can support 4 very key features: ultra low latency. So it can make decisions, make inferencing as fast as possible. Again, how fast is that depends on your communication and your device capacity. So you cannot actually put a baseline. It would be this much microseconds or milliseconds. Since you are working on the machine itself, you can adapt to environment very quickly. For example, if you're running your edge artificial intelligence model on your autonomous self-driving car, that edge AI model can sense the surrounding and take action like braking and speeding and those kind of things. Same in manufacturing, the edge AI installed on your CCTV camera can see whether and worker safety is compromised or not. So those kind of things can be done really quickly, including ultra low latency, and also it can take actions called real-time actuation. Then there's other benefits like privacy, especially in healthcare. If you're using edge computing and sensors to monitor the remote healthcare of elderly patient, it can take actions like informing the GP clinic or calling the ambulance. All those things are possible through edge AI. I'm not saying it's not possible through the cloud AI, but it would be a bit slower and a bit cumbersome to implement. And maybe it will compromise privacy, and real-time actuation will be slower. But again, depends on the comms per se. So what's the groundbreaking research question that we want to deal in the hub? The groundbreaking research question is that we are dealing with how to ensure safety and security of AI and data from known and unknown cyber disturbances in the edge in real time. Again, cyber disturbances is a broader term than cyber security. So cyber disturbances includes all those cybersecurity attack challenges. Along with that, it includes those cyber resilience challenges like faults, failures, software errors, hardware errors, network congestion, network problems, and all this together manifest into cyber disturbances. And our research has shown that all this manifestation can actually impact two symbiotic things: the real-time learning quality and real-time data quality. So if you know, most of the cloud paradigms is based on historical training and again, model retraining, those kind of paradigms. But what we are looking in edge AI, the new hypothesis is how can the edge AI models can train itself through paradigms such as lifelong learning in real time. And because it's going to train itself under autonomous setting, the data quality becomes a very critical issue, because if data quality is compromised, the training will be compromised. So that gives us our grand challenge of how do we ensure that edge AI is safe and secure in this real-time environment, and it is protected from not just known cyber disturbances but from unknown. And what I think about unknown is something, because in edge computing, there are new and new devices are always added to the ecosystem, and we don't really understand how those devices behave in terms of comms, in terms of hardware, software updates, and that just create the bugs that we are not aware of, and that can actually compromise your model quality and learning quality. So ensuring that is a very, very difficult challenge. So our vision for the hub is to deliver world-class fundamental research co-created with companies. So whenever I have meeting with UKRI, working with companies is the key. They do not want us to work as the typical university lab where we write papers and publications. They remind me all the time. So working with companies is our key thing. And my last meeting was yesterday, by the way, in one of the other hub launch. So this is quite important. So how do we protect the quality of data and quality of learning with AI algorithms when they're subjected to known and unknown cyber disturbances? Just to give a brief overview, I give a broad picture, but we still need to organize this research in a bit methodological way to really help our company. So what we have done is we have separated our research into 5 work streams. So 2 of those work streams are on socioeconomic gains, and 3 of them on the research. So work stream 1 is about how do we engage with community like this one, how do we work with companies and gather their requirement of edge AI or distributed AI or federated AI, and try to feed into our research themes. And based on those input, we have designed 3 different research themes. First research theme in cyber disturbances modeling. For example, can we model what cyber disturbances attack surface exist when you deploy your AI algorithms in cloud edge IoT continuum? Right? How do we model that? Currently, there's no knowledge base available for that. Of course, a lot of knowledge is in different blogs, different white papers, different publications, but how do we bring it together? And since there's so much information available, we have started looking into LLMs to compile those information. So we have hired a postdoc to do that, because that will simplify our job, because a human reading all those papers all the time is not going to scale. So we are actually relying on AI in that work stream to actually develop our knowledge base. Then in work stream 3, we are looking at with different kinds of AI algorithms, how can we adapt their optimization and their deployment on different kind of edge devices? Because edge is quite complex and heterogeneous. There's no one size fit all approach that works. In cloud, because of virtualization, it works like on GPUs. And even if it works on different operating system, you can use Docker or any other virtualization engine. But in edge, it's not easy to run virtualizer on the device. In some cases you can, in some cases you cannot. So that's why in this workstream 3, we're looking at Edge AI as a service where the developers can come, give the AI model, and this component can just translate those Edge AI code into something that is easily transportable and portable to the underlying devices. And so that developers don't have to worry about the underlying specific of how to do recalibration of the model. And then in workstream 4, we are looking at if we detect cyber attack or cyber disturbances event, can we guard our data quality and model quality? Can we heal it? Or can we mitigate it? Mitigate could be maybe harder, because not all attacks can be mitigated, but we are looking at, can we reduce the damage to your AI pipeline, AI system? So that's the ethos of workstream 4. And then in workstream 5, based on the input from all these 3 workstreams, we are looking at having a demonstration, studying real-world use case of autonomous transport, healthcare, and energy. So just to give, as I said, workstream 2 is about how to understand the attack surface on when AI is deployed in edge cloud IoT continuum. And we are taking the approach of modeling and developing a community-driven knowledge graphs where all those the attack properties will be coded, and we are opening that knowledge graph for the community to update on ongoing basis. And hopefully that will provide a baseline to understand what are the challenges. In line with that, currently, we are in process of setting up a AI safety lab at Newcastle with Lenovo. So Lenovo is quite interested in this area, and they are very happy to set up this joint safety lab at Newcastle, where the idea is the companies bring their AI pipeline, AI devices, and we actually attack it through the attack models and tell them what's your attack surface and how vulnerable you are based on your deployment context. Because as you know, in cybersecurity, your attack depends on whether you're running in trusted domain or untrusted domain. Not all attacks are relevant to all deployments. So Lenovo and Intel and NVIDIA are interested in that, setting up a joint lab where companies can bring the AI pipeline, we attack it, and then give them some vulnerability score, for example. And I said in workstream 3, we are looking at how do we deploy different AI models on heterogeneous devices. And as part of this work stream, we have postdocs at Imperial, Southampton, St. Andrews, and Newcastle. So this is part of Edge Computing for AI research theme. Then in work stream 4, we are looking at, as I said, how do we heal and mitigate those damages when attack happens. So for this, we have postdocs at Swansea, Cardiff, Newcastle, and Durham. They're looking at different aspects. So while we are doing that, we are getting a lot of companies to work with us, and especially we get a lot of interest from defense sector. So we are trying to modify our themes a little bit to align with that. So that was the ethos of how anyway we set out a vision, but vision is quite broad. We can always change it based on what company needs. So we have started working with 2 very major defense provider in how do we ensure safety of federated learning on drones, for example. This is a quite specific case of Edge AI, and the attack surface is open because they want to deploy in the mission critical situation. That gives a lot of challenges. And then coming back to like how we work with this community, I think what I believe, because my research background has been in cloud interoperability, multi-clouds and hybrid clouds. So I have done a lot of work on that. Of course, these days I'm doing Edge AI. Maybe that's because there's a lot of money there. So, but I mean, all the universities are working like that. But I think what I believe that federated learning paradigm or distributed learning paradigm is the holy grail to solve all those interoperability problems to some extent, especially, it will release the burden of moving data away from the source. So, and we don't have to rely on data lakes or data warehousing, those kind of solutions, because federated learning solves that problem for us. So obviously in federated learning, the issue with this AI or distributed system is the things keep emerging. So now we started federated learning. Now they are saying we have horizontal federated learning, we have vertical federated learning, and they also say we have transfer federated learning. So I didn't put transfer here, but I just put 2 of them. So in horizontal federated learning, all participants have data with the same features, like different banks trying to understand the fraud behavior. The feature space is same. In vertical federated learning, all participants have data with different features. So you are trying to learn a global middle from different features, like a bank want to understand the customer credit history based on different shopping behaviors. And again, how horizontal or federated or vertical federated learning is implemented based on your use case. It's banks, it's healthcare, it's quite different. And also, based on the deployment context, the attack surface will be different. Like I was saying about the drones, right? Even within the drone federated learning, you can have so many different architectures that I'm showing in this picture, where your drone can be both the global model server in the first part of the picture, or the drones can be talking to the cloud in the second one, or drones could be talking to the cars, and you have a heterogeneous federated learning system. So if this kind of federation, of course, this is different than federating data center, the challenges still exist. And you are saying here you are federating heterogeneous things. You're not federating heterogeneous servers, unlike in the cloud computing. So here, how do we ensure that your federated learning is safe and secure is really, really challenging. And in fact, for some of these applications, we don't even understand the attack surface. And that's why the defense sector is working with us, because they want to use it, but they are a bit scared to use it because they don't know what can get them, whether their drones can be spoofed or fooled at runtime and the drone just flies somewhere else through GPS spoofing and those kind of attacks. And also I wanted to show how federated learning works for say healthcare. So this is a vertical federated learning for healthcare application, where different hospitals have different data sets about genomes, about ECG and others, and then you are trying to learn the global model, like how certain disease leads to certain outcomes. So this is how federated learning will happen for the healthcare. And again, this will be very different than the drone scenario, right? So your attack surface changes, your data flows changes, and control flow changes. So I think from the hub perspective, we are not about resource management or data management, because that's are very important problems, but that's not under our focus, and we won't be focusing on that. And unfortunately, there are no hubs focusing on that either. So I don't know who is going to look into that, but possibly so UKRI will have a call on that, maybe in the future. But because our ethos is looking at how to make AI safe and secure, right? So we are looking on federated learning attack models. And just to give you a snapshot, like what attacks are possible, right? Again, these attacks are not relevant to all federated learning or all federation scenario. It depends on your deployment context, depend whether you're running, whether your data is hosted in a trusted domain or untrusted domain. But these are the common kinds of attack that we understand from the literature, like integrity attacks, privacy attacks, like disrupting the convergence of the model, data poisoning, backdoor injection, inference attack, gradient leakage attack, model stealing attack. Again, this is not an exhaustive list. There are a lot of surveys published on that. So we understand what attacks are possible, but what is missing in the literature from company's perspective is we don't have the attack code. They don't have the attackers available where if they implement a federated learning system, can we attack it and show what is happening? The attack modules are not available. So we are working as part of the AI safety, developing these different kinds of attacks. At the same time, what is not available is the healers. If attack happens, how can the federated learning platform can heal itself, protect itself? That part is also missing. And even the literature on that is not very vast, how to heal, because healing has different meaning. You want to heal the data quality, is a different problem. You want to heal the network comms, is a different problem. You want to heal the model quality, it's a different problem. So companies need help on those perspectives. So just to go in more detail, I'm not going to give a lecture on different kinds of attacks, but these are attacks possible, and their modes of execution and how much impact it has on your edge AI pipeline or federated learning pipeline depends on your deployment context. One of the major point I would like to make here is we are a consortium of 12 universities. We have a lot of skills and talent distributed all across the UK. So we have universities from Wales, from London area, from Midlands, from Northeast Scotland and Northern Ireland. And we have experts in edge computing, applied AI, application experts, cyber resilience, foundational AI, policy and engagement. And we also have companies from all those places as well. So we are quite well equipped to work with any company from any part of the UK. And based on based on what company needs, we have a lot of flexible money available to create extra capacity within the hub. So we have set aside £1 million, like based on if X company needs some special help, we can create extra postdocship aligned with that company. So we have a lot of flexible pot. But again, that is dependent on how much money company is willing to put on that high risk, high gain project. But what we are saying is, if you're willing to take the risk, UKRI and Hub will also take the risk, and we will also invest and try to solve your problem. And that kind of model is actually working quite well with the companies. I think with that, I will stop my talk, and thank you very much for listening. Thank you very much.
Questions?
Hi, thanks so much. Really interesting. On your last bit about the potential for attacks on models, that's something that I've not been leading on, but I've been involved in. I don't know if you've read about the grey matter green paper that we wrote 2 years ago, looking at the privacy risk of attacks. And in a subsequent project, we've looked at trying to develop both mitigation mechanisms and also how do you quantify the risk? Because if you're worried about the risk, then you need to identify, where is it a big risk or is it a small risk? And so we've developed some tools to try to identify that. So I think there's some opportunity for us to
collaborate
together on that. Yeah.
So we are going to have a pump priming call this year, where we want to attract like your research groups to work with the hub. And I know we would be looking for this kind of already developed knowledge base to come to the hub. So I think let's talk after this event. And I think, we would be very keen for your groups like you to apply into pump priming, get money from the hub, and, integrate and work together actually to solve this problem. So I think that's a great opportunity.
So this is going to be a very ignorant question because I come from a federation point of view where you identify like a person or a service or a site or facility. What happens in federated learning? How does how like something says I'm part of this federation?
Yes, so that depends on your federated learning architecture.
Okay.
So if it's a closed architecture, then everyone knows what they're doing. If it's a closed system.
Okay.
But if it is based on the old hypothesis of peer-to-peer federated learning, like, that we had Napsters and Kazas, where anyone can join anytime, that's where the problem is. But my feeling is no company is going to do that because that's too unsafe.
Yeah.
Because you can't let anyone just join in. But of course, there's a benefit of that, like in healthcare, if all we aggregate all this hospitals data and try to do this, which is never going to happen because of privacy and GDPR, but there's a lot of advantages that, but trusting the federated learners in open system or either the internet is impossible. It's never going to happen in my opinion, at least for mission critical application. But if you look at more futuristic, that government wants to be like autonomous transport, right? Where the cars wants to learn from each other. They want to do that, but then there's no clear indication how a car will authenticate each other with all the time, and how to avoid someone injecting a malicious cars into traffic. So this is again, I don't know, the DFT and other need to look into that. They want the transport to be autonomous, but this big problem will exist. And there's currently no solution to ensure that no malicious cars is misguiding other car or misguiding the network, like roadside units and those kind of things. So I think this is a new challenge for us, like combination of AI plus federation plus networking and cybersecurity. It will keep us busy for next 10, 15 years.
Funded. Yeah. Yeah. No, so just like a quick follow on if no one has a question. So when you say a closed system, does it mean it's like a vendor, like you go with a single vendor or supplier or a single environment or legal entity? What does it
The closed system means you can establish the identity of the devices.
Okay.
Through
some standard protocol. Are there standards right now?
Just semi-authorization, authentication, just the standard trust establishment protocols.
Okay.
You can do that. Because that's like, if when I'm talking to defense, the drones they fly is
okay.
all authenticated, right? I think that's the way to go. Otherwise, your attack surface just gets bigger and bigger. You cannot actually control it.
This isn't something I'm particularly well versed in. I might have to wash my mouth out a bit afterwards as well. But I'm wondering if that sort of open peer-to-peer use case, because I was going to raise the exact example you gave of autonomous vehicles. I wonder if that is a use case for blockchain.
Yeah, the blockchain is the other. I mean, blockchain, again, permissionless or permissioned, right? So again, if you go permissionless, the trust is still a problem. If you go to permission, then it becomes one of the other way to establish trust. I mean, at some stage, if autonomous transport has to become really prime time, the car vendors have to sign up some certain kind of trust establishment where the trust is on the hardware, not on the software, like TPMs kind of technology. And then if they authenticate through TPMs, then maybe we reduce the attack surface. But it's not happening right now. And of course, if they open a V2X communication, that just becomes really, really hard to control the attack surface. Everything can just go wrong in the traffic if something malicious is injected. But again, it's very good area to write proposal, get money, and write blue sky papers and grants. So yeah.
Could I just ask about the application? I didn't quite hear, but do you have any applications that have or are related to, for instance, users of a building?
No.
Who's navigating on a building and
No, smart
using
buildings.
this mobile.
No,
Okay.
we don't. Because we don't, I think buildings we say is more like a closed system. So I don't think the challenges are that much. I mean, there could be, we can always cook up a scenario where everything gets hacked, but normally they are behind a firewall and it's very hard to get into those kind of systems. It's like a data center, right? It's hard to penetrate the security of data centers.
But what I was meaning is people walking in and out.
I mean, I know it's possible, but it's not as easy as Edge.
So I think it was meaning the people walking in and out of to the building.
I mean, if you are talking about people-to-people communication and you're using that information to make decisions, then it's open system, then it's a problem. Then it's not about building, then it is quite relevant to VTX communication, everything talking to everything. So it's based on what your communication pattern is and whether the communication is between trusted parties or untrusted parties. I think that's the key here.
Again, this is not my field, but do you think, I've heard of the term system of experts, and I imagine that's very relevant for Federation of AI. It's like a concierge service between lots of different trained AIs, and they kind of hand off to each other.
I mean, they call it agents these days, multi-agent AI. So that's the new name. But yeah, it's multi-agent systems. Again, it depends on your application, actually. And most of the application that we talk to companies are closed application, like healthcare or drones or autonomous car. Like even for the cars, companies in Coventry are saying they will just talk to their own breed. Like, Rolls-Royce, we talk to Rolls-Royce, Range Rover. They are not going to talk to everyone. So most of the thing, I believe, the real-world deployment where it can impact our critical infrastructure will be a closed, trusted system. So I think in those cases, more than cybersecurity, cyber resilience become a problem, like faults, failure, hardware bugs, software bugs, which is beyond the attacks, right? That is just normal human error. And if developers are using LLMs to code their software, then those kind of things. So cyber resilience will be more important than cybersecurity in those kind of closed systems. Thank you very much.
Thank you very much. And a big thank you to all the speakers on this session. We'll now have a 30-minute break for some tea and coffee, and we'll be back for the plenary discussion at 4. Thank you very much, everyone.